Welcome back, guys. Today we have a high yield orgo problem for the MCAT, and today we are given R2-butanol, and we're told that it has a specific rotation of positive 13.9 degrees. We are asked which of the following best describes the expected optical rotation of S2-butanol under the same conditions. So for the MCAT, super high yield for you to know the three scenarios in which you can find the numerical value for the optical rotation. That is enantiomers, diastereomers, and a 50-50 racemic mixture. And so if we look at our image here, we have R2-butanol, we have the enantiomer here, S2-butanol. Remember, an enantiomer means you flipped all the chiral centers, right? A chiral center, 4 different groups attached to a carbon, right? We flipped the chiral center from R to S, and we only had one chiral center to begin with, so that means that we flipped all of them. That means that we have an enantiomer, and for the MCAT, if we have a rotation of positive 13.9, we're going to flip it to the equal and opposite sign. So whatever the number is, you flip the sign. So in this case, it's negative 13.9 degrees, making B the correct answer here. If we work through some of the other incorrect answers, positive 13.9 degrees, this is wrong. This is our R2-butanol, right? We already have the R2-butanol. We flipped it to the enantiomer to find negative 13.9 degrees for our optical rotation. C, only pick 0 degrees if they tell you you have a 50-50 racemic mixture. So that means that you have a 50-50 split evenly down the middle, the exact same amount of your R and S enantiomer. We have enantiomers here, but they did not tell us that it's a 50-50 racemic mixture, so we do not pick 0 degrees. The reason it's 0 degrees is because when you have a 50-50 racemic mixture, right, the optical rotation actually cancels out because you have an even split of that positive value and that negative value, right? And so it didn't say racemic mixture, so we did not pick 0 degrees here. And lastly, positive 27.8. You would pick a value like this if you had a diastereomer, right? So when you have diastereomers, the rotation value you pick will have nothing to do with the value that they give you, right? The reason we did not pick this here is because this is not a diastereomer. The 2 ways you can have diastereomers on the MCAT, if you have E and Z double bonds, that's one way to have a diastereomer. The other way is if you have a molecule with multiple chiral centers and only some change but not all, right? That would be a diastereomer, and you would pick a value like this. However, all of our chiral centers changed, so this is an enantiomer, and B was our correct answer.